Like anything else in life, window functions have their limitations and drawbacks. Let's look at some of those today. Welcome to this video on window functions. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video, we looked at some great use cases for window functions. In this video, I want to flip the script and take us through situations in which window functions will fall flat. Let's go to the classroom and see a couple of examples of things you cannot or should not do with window functions. In this first example, I want to walk through a common annoyance with window functions. Here, I have a simple window function query. From dbo.table, I am selecting column 1 and column 2, and then performing some window function, calling the output WF. So far, this is perfectly reasonable. But what if I want to filter where WF is greater than 5? Well, this will not work. I will get a syntax error with this query. The same is true if I try to group the results by my window function output or include them in a having clause. Again, using the output of a window function in either of these clauses will give you a syntax error. But if I have a window function output in the order by clause, well, this will work just fine. The reason for this has to do with the way SQL Server logically processes your query. We write a SQL query starting with a select clause, but SQL Server doesn't process the query for syntactic correctness starting from the select clause. No, it starts with the from clause. Then we include the on clause and incorporate any joins. Left, right, inner, outer, cross, doesn't matter. They all show up right here. After those two, we have the where clause, which filters non-aggregated data. The group by clause allows us to aggregate our data. There are a couple of clauses that we use with groups to generate results, with cube and with rollup. Those are very uncommon outside of certain analytical queries, but they nestle in right here. Then the having clause allows us to filter results after we have aggregated the data. Finally, we get to the select clause. If you're keeping track, that's the 8th item on this list. Then we get to the distinct clause, followed by order by, and finally top. Now, this ordering covers the vast majority of queries, and I'm not going to focus on weird edge cases, although if you want to list some in the comments, you're welcome to. But the whole point of this little diversion is to note that the select clause comes in 8th place, after where, group by, and having. This is the reason why we cannot use an alias that we would define in the select clause in these earlier sections. But we can use the window function results alias in the order by clause because the binding order is later than the select clauses. All that said, what is the workaround? Well, we've already seen this. Slap that query in a common table expression or a subquery. As a member of the Common Table Expression Appreciation Society, my example includes a common table expression. But if you are a member of Team Subquery, the behavior is exactly the same. Within the CTE or subquery, we need to obey the binding rules that SQL Server has in place. But then, in the main query, we can treat the results of the common table expression or subquery as a virtual table and the aliased window function output as just another column. So now it's kosher to include our window function result column in the follow-on queries clauses like where, group by, having, and even on. The next limitation I want to talk about is a limitation to frames, especially range. In T-SQL, we get 4 official ranges. The first is range between unbounded preceding and current row. This goes from the beginning of the frame up to and including the current row. This is helpful in cases where we have running totals. Next is range between unbounded preceding and unbounded following. This covers the entire frame from beginning to end. We can use this in cases like getting a grand total. The third option is range between current row and unbounded following. This is almost the opposite of a running total. It's pretty rare to see this option in action, but we could probably come up with some kind of scenario like how much of some total is remaining. Finally, we have range between current row and current row. This is technically possible, but honestly, it's kind of dumb. I imagine there might be some reasonable situation in which this is a clever solution to a business problem, but I've never seen it in action. These four are neat and all, but SQL Server is missing something big: intervals. The ANSI SQL standard has some support for time intervals, and we do see a few data platform technologies like Postgres that support them. Here are a couple of examples of what interval support would look like. First, we have a range from 1 hour ago to the current row. Or maybe we want the range from 7 days ago to 7 days from now. In both of these cases, we don't define how many rows to go back. We define for some given date column that we would need to specify that we want all records that fit within this range. This is particularly important with time series functionality. I want to know records that fit within a certain time frame, not necessarily a certain number of rows back. As a practical demonstration, I've repeatedly had to mention with the lag and lead functions that we are looking at the number of rows back, not an amount of time back. And if there are gaps in time, lag and lead happily go back the requisite number of rows, regardless of whether that prior row is 1 day ago or 6 months ago. This functionality would be very powerful, but it's not in SQL Server 2022, and it doesn't look like it's going to be in SQL Server 2025. It may make it into a future version of SQL Server, but we'll have to wait and see. For our final limitation, I want to show off a demo, so let's head out of the classroom for that. Here we are in Visual Studio Code. I'm going to recreate a demo example that we saw in the prior video involving event attendance. To refresh your memory on this scenario, the idea is that we track attendance at a weekly event. There should be one event per week, but due to a bug in the application, we have some weeks with duplicate rows. Our goal is to remove these duplicate rows. Now, I showed a good way to remove those rows. Use row number within a common table expression to generate a monotonically increasing sequence of numbers for each event date. The first instance of a given event date will show up with row num equals 1, and any duplicates will show up with values of row num greater than 1. But let's say that you then learn about the apply operator, and you think it's the cat's meow. It is, of course, the cat's meow, so you're right in thinking that. But let's rip out this common table expression and throw the query in a cross-apply operator. When I run this, well, the results are weird. Everything has a row num of 1, and that's not right. So what gives? The reason for this comes from the way that cross-apply operates. Think of cross-apply as a function that applies for each row of an input. The context of the apply operator is the row, not the table, or combination of tables if you have joins prior to the cross-apply. When we specify a window function across our input, our frame can only be a single row. That is the row that we are inputting into this particular invocation of our apply operator. For that reason, row number will always return 1 despite our best wishes. For that reason, don't combine the apply operator with window functions like this. The results that you get will not be what you anticipated. That's going to do it for limitations in today's video. It's a fairly short video, especially compared to our discussion of use cases. But I think that's because window functions are extremely powerful. They are very useful and don't have a huge number of limitations. Now, the next video will wrap up this series, and in it, I'll look at performance characteristics of window functions. We'll have links and show notes in the description below. And until we see each other in the next video, take care.